All right, we're going to take a look at a couple examples of inverse problems from the lesson we just heard. These are just different examples that have been in different AP review books. Our first one, it says let f be a function defined by f of x equals x cubed plus x if g of x equals the inverse of f of x and g of 2 equals 1, what is the value of g prime of 2? All right, well, remember what we said, that if they are inverses of each other, the derivatives at the corresponding points are reciprocals of each other. Well, let's see what we have. If g of 2 equals 1, and g is the inverse of f, that means f of 1 equals 2. All right, well, that means that the derivative at f of 1 would be the reciprocal of the derivative of g of 2. Well, let's see if we can find the derivative of f of 1. Okay, well, derivative of f of x we can find from the function. That'd be 3x squared plus 1. So the derivative of f of x equals 1 would be 3 times 1 squared plus 1, which gives us 4. So if the derivative of f of 1 is 4, then the derivative of g of 2, that corresponding value, should be 1/4, which is answer choice B. All right, again, derivatives of the derivative of a function and its inverse are going to have reciprocal values, okay, at those corresponding points. All right, let's look at another example. Okay, let f be a differential function so that f of 3 equals 15, f of 6 equals 3, f prime of 3 equals -8, and f prime of 6 equals -2. All right, the function g is differentiable, and g of x equals the inverse of f of x for all of x. What is the value of g prime of 3? All right, well, that means we need to figure out our corresponding point first, and then look at f, because we have a whole bunch of values of f here. So g prime of 3. Well, that means that f, or g of 3, f of something has to equal 3. Well, look at our examples here, or our information. We got f of 3, we have f of 6. There it is, equals 3. So that means these are your corresponding points, 6, 3, and 3, 6. Well, then we should be able to look at our information for f prime of 6. And f prime of 6 is -2, so that means g prime of 3 is the reciprocal, which would be 1/2. And then if we look up here, there it is right there, value A. All right, let's go to the back side of this. All right, this one's a little bit more challenging. We're looking for g prime of 0. All right, let f of x equal x cubed minus 7x squared plus 25x minus 39, and let g be the inverse function of f. What is the value of g prime of 0? Well, for starters, we need to find that corresponding point. So if g prime or g of 0 has to equal something, then f of something has to equal 0. Well, we have f of x. So let's set f of x equal to 0 and see if we can solve it. Now this one is one that can't be factored. So really the only option we have, we could do rational root theorem P over Q, but this would probably be a calculator question. And we're going to talk about the calculator tomorrow, but here is my equation. I'm going to put that right into y1. And if I graph this, I can see that it crosses the x-axis at 0. Or at 3, x equals 3, y equals 0. There it is right there. So x equals 3 for this one. If I put the 3 there, that means g of 0 equals 3. And we go ahead, we're trying to find g prime of 0, so if I can find f prime of 3, I can just take the reciprocal of that. Well, here's my f of x equation. So f prime of x is going to equal 3x squared minus 14x plus 25. And if I put in 3 into that, you'll see that you'll get 10. So if f prime of 3 is 10, g prime of 0 would be 1/10. All right, our last one just says, what is the derivative of the inverse of f of x? Well, we need to find the inverse of f of x. So remember what I said, set f of x equal to y, switch x and y, solve for y. Well, how do I get rid of this negative 1/3 power? I raise both sides to the negative 1/3 power. So there is our inverse of f of x. Well, take the derivative of that. Derivative of that would just be negative 3x to the negative 2nd power, which, negative 4th power. Scratch that. Gotta make sure you subtract, and that's going to be e right there. All right, so these are just a couple examples of inverse problems that could pop up on the exam.